Hello all. Yesterday, you guys had a lesson on the properties of a parallelogram. Today, we're going to talk about the ways to tell that any quadrilateral is a parallelogram. Fortunately, the properties of a parallelogram line up very well with the ways to tell that any quadrilateral is a parallelogram. So what we're going to do is walk through the examples and see which ones are parallelograms, which ones aren't, and get used to using those properties. Okay, the first property of a parallelogram was that opposite sides are parallel. If you see a shape and the opposite sides are marked parallel, that's enough to show that that parallelogram or that quadrilateral is a parallelogram. Okay, so look at the examples under number 1. That first one, notice the top and the bottom, here and here. Both of those have the double arrow that indicates the top and bottom are parallel. And again, on the left and the right, the single arrow indicates those two sides are parallel. So based on the markings, yes, that is a parallelogram. The second example, the top and the bottom have a single arrow, so those must be parallel. The left and the right match with the double arrow, so again, that shape matches the property of opposite sides being parallel. This last one, the left and the right, the single arrows match. But the top and the bottom, notice nothing's there. So you can't tell for certain whether this is a parallelogram because you need both pairs of opposite sides to be parallel. This one just doesn't really have enough information, so go ahead and put no. The second property of a parallelogram is that opposite sides are congruent. So if you see that marked on a shape, you know it's a parallelogram. For number 1, the double hash on the top and the bottom indicates that those two sides are congruent. The left and the right, those are marked the same, so those are congruent. So this would be yes, opposite sides are congruent. For the second one, the left and the right both are 6 units long, so those are the same length. The top and the bottom are both 4 units long, so those are the same length. So yes, the property applies here. This is a parallelogram. For the third example, the left and the right are congruent. They are marked 5 and 5. The top is 7, but notice with the bottom, there's nothing marked here. So we can't say for certain that the top and the bottom are congruent, so the answer here would be no. For the third property of a parallelogram, that opposite angles are congruent. If you look at the one on the left, we have double mark and double arc in the corners, so those opposite angles are congruent. Single arc in the bottom left and upper right, so those are congruent. So yes, we have opposite angles are congruent. For the second example, notice there's something missing. This bottom angle is not labeled. So what we need to do is find that so we can compare the angles here. Remember from properties of a quadrilateral that the angles of a quadrilateral always add up to 360. So what you would do is take 360 and subtract the angles you're given. 360 minus 100 would be 260, minus 70 would be 190, minus 70 again, 120. So that missing angle is 120. Well, that creates a problem here because although this pair of opposite angles are congruent, this pair is not. So this one would be no because the opposite angles are not congruent. The fourth property of a parallelogram was that diagonals are bisected, meaning the diagonals cut each other in half. If you look at this example, along this diagonal, we have 2 congruent halves. Along this diagonal, again, 2 congruent halves. So this is yes, the diagonals are bisected. Second example, along this diagonal, these 2 halves are congruent. Along this diagonal, these 2 are congruent, which means, again, the diagonals are bisected. If you look at the third one, along this diagonal, the markings are different. Double arc, double hash, single hash. Well, that creates a problem because that means that those 2 segments aren't necessarily congruent. Same problem exists along this one because the bottom part and the top part are not necessarily congruent halves. So in this case, the diagonals are not bisected. For the fourth example, this diagonal is clearly bisected because we have the same kind of mark on the 2 top and bottom parts. This diagonal has no markings at all, so there's no way to be certain whether this part is the same as this part. So this is a no, not enough information. For the fifth property of parallelogram, all pairs of consecutive angles are supplementary. So what you need to check is if you add up any 2 consecutive angles, which remember means angles that are next to each other, they have to add up to 180 degrees. Okay, so if we look at this example, say the 2 bottom angles, 100 plus 80 degrees is 180 degrees. So those 2 consecutive angles are supplementary. The same pattern exists on the right side, 100 plus 80. 100 plus 80 on the top, 100 plus 80 on the left. So every pair of angles that are next to each other adds up to 180 degrees. So this one is yes. The second one, we know that 100 and 180 do add up to 180, so those angles are consecutive and supplementary. But what about these two, or this pair? Because we don't know what this one and this one are, we don't have enough information to say that all the pairs of consecutive angles are supplementary. So the answer for this one would be no. The last property of a quadrilateral is that one set of opposite sides is both parallel and congruent. The critical part of this property is that one set of opposite sides. So if you look at the first example, this is the case. The left and the right side have the parallel markings, which are the little arrows, and then the congruent markings, which are the dashes. Because this one set of opposite sides has parallel and congruent, this matches the property. Example 2, one set of opposite sides, well, the top and the bottom in this case, they have the parallel, which is the arrows. The 4 on the both sides indicates that they are actually congruent. So again, yes, one set of sides is parallel and congruent. Now here's the really tricky case. This third example, we've got one set of sides is parallel, that would be the top and the bottom. One set of sides is congruent, that would be the left and the right. But the markings are on two different sets of sides. It has to be one set of sides, both parallel and congruent. Because the parallel are on top and bottom, congruent are on left and right, this does not match the property. The markings have to be on the same pair of sides. Okay, so be careful about that one. That's probably the trickiest property. That's the 6 properties in order to tell that a quadrilateral is a parallelogram. I hope you liked the lesson. See you in class.